Okay, here we go. Hey, welcome back, everyone, to another wonderful MRWC recording of Activity 7B2. Wow, isn't this lovely? It says, draw a possible sketch graph of a polynomial function that has all of the following characteristics. Well, what is it? The domain is all real numbers. I can handle that. The range is from negative infinity to positive 3. Let's mark that real quick. So 3 is like right here. I'll put a little 3 here. That's how high we're going to go. And then it says there's two x-intercepts, both negative. They didn't specify where, so we'll have like one here and maybe like one there. There is one root at one of the x-intercepts and 3 at the other. Well, let's make this one here the triple root. And this one here will be the single root. Oh, it is. So if that's there, then, so we have a triple root, and the 3 just means, let me actually write triple, because you might get confused. So this one here is triple. Triple root there, single root here. So we're going to come, so this right here is degree 4. And degree 4 means it's going to, if it's positive, it's going to start, metaphorically start, it's going to start up there, and it's going to end also in positive infinity land. It doesn't have to be all the way over, but we could certainly do that. And let's just, before you draw it, I recommend you do a dry run. You just motion with your hand where it's going to go. So we're going to come down here, we're going to hitch, and we're going to come through and through 3 and go to positive infinity. So let's do it. Let me do this here. So we're going to come down. Now it's going to hitch like a cubic. Then it's going to come through without hesitation. And it's going to do that. And it goes to positive infinity. And that's it. That is my graph. Does it have all real numbers? Yes. Because we're assuming that this keeps going like that forever. And this one here as well. So the x values are all covered. Oh, wait. Nope. I screwed up. Did you see how I screwed up? I screwed up. Do you know how I screwed up? What's this? What's the screw up? The maximum was supposed to be 3. Okay, so if maybe it would have been better if I did a little helper line for me, right? And say it cannot cross that dotted line. And now let's try again. Maybe we can start from down here. So we can go up and through. No. I bent too early. I didn't want to bend so early. So it does this. It goes all the way to 3 and comes down and does that. Yeah. Yeah. Right, so it keeps going in that direction. It keeps going in this direction. And that way it will cover all the x values. We have the hitch at negative 4. It goes up to positive 3, inclusive. And it has degree 4. Yeah, it goes back down. Okay, let's do another one. Let's do letter B. I'm sorry, what was the question? Okay, never mind. Yes, Kiki. I mean, student. How did I get what? Oh, those are random. I just arbitrary. Those were arbitrary because they didn't specify. They just said both negative. I couldn't put them anywhere. Yeah, anywhere negative. That is. Yeah, -2, -4 were just choices I made. Yeah, that was completely arbitrary. Okay, number B. The domain is discrete. Lovely. The function is not defined for values of x less than -2. Okay, so this time I'm going to draw a line here. And let's move it ever so slightly. Close enough. Okay, so this time it's not defined for values of x less than -2. So it could actually be 2. -2, I mean. It could actually be -2. It's just not defined for values less than -2. There's only one root. The y-intercept is negative, and the x-intercept is positive. Okay, so we have a y-intercept negative, so let's mark that down here. An x-intercept is positive. Let's mark that right here. And the domain is discrete. Okay. In that case, let's make it like a line. The simpler the better, I always think. Because simpler makes more sense. So what we're going to do is we're just going to do a line that has a slope of 2. And I'm going to go off the grid here a little bit. Yeah, I know. Okay, so what I'm trying to say is we have a slope of 2. And it just ends. Okay, so on this side up here, it will keep going. But here, down here, it'll terminate on that line. Okay, so it's discrete, meaning it's disconnected. It's not a continuous line. So it's disconnected, and that's how we get our discrete domain. But you could still see it being a function, right? You could say, hey, this is y equals 2x minus 4. And so if it's y equals 2x minus 4, it's clearly a function. And then just, or I'm sorry, not y equals 2x minus 4, y equals 2n minus 4. Because if it's n and not x, then I only have this integer, or yk, okay, y equals 2k minus 4, and then just limit the domain to integers equal to or greater than -2. Well, I did say polynomial function, and a line wouldn't really. But that's splitting hairs at this point. We could just switch it to like cubic and be fine. Okay. All right. Should we do another one? Let's do another one. Let's do C. The domain is all real numbers. The function has 3 x-intercepts. One x-intercept is negative, and the other 2 are positive. Okay, so I recommend that you pause the video and try this out yourself. See if you can figure it out, and then watch my explanation. And welcome back. One is negative. Let's use a different color. We already used red. What? Your what? Let's move on. And the other two are positive. I don't think it matters where they go, so let's just like pick some numbers here. Okay. There are 3 roots at one of the x-intercepts and 2 at the other. This is pretty easy. I'm very sorry. It's a lot easier than you think it is. Because you can almost do anything. As long as you have a hitch on one of them and a bounce on another. And then the third one you just go through. And there you go. Why not? You know, there are other ones we could have done. Obviously, those 3 dots, the placement of the 3 blue dots is arbitrary. I can't zoom in anymore. But also, you know, I could have done this way. I could have done hitch and then bounce here. I could have also done hitch through and bounce. I could have done that. Or I could have done bounce and hitch and through. Or I could have done bounce and through and hitch, right? There's a lot of different possibilities. All of those would have met the requirements, and that's why I said it was easier than it looks, because there's so many different possibilities that you could have done for that one. Equations. Oh, yeah. Write a possible equation for a polynomial function whose graph is shown. Now, this is much more like the quiz. So remember, we're supposed to have a quiz soon. And the quiz deals much more with the equation. So let's have a look at this. You may use a graphical tool. No. No. We don't do that. So let's look at this. A possible equation. Well, again, if you remember IM3, Chapter 8, this is basically what we did. Don't do that. So here's what I recommend. You take the x-intercepts and you make them the 0 of a binomial, like this. So minus 1 right here, that's going to give you x plus 1. This other one over here, x minus 3, that's what you get from this one here. You just make that the 0 of the binomial. And then, after you've done the x-intercepts, then you think about bounces and hitches. Do we have a bounce or a hitch or nothing, or what? Looks to me like we have a bounce. We have a bounce at 3. You know what happens then? Excellent. Well done, guys. Yes, you square it. And is this graph positive or negative? Okay, do you want to know the trick? There's a cool trick that I want to show you guys. How can you tell if it's positive or negative just by looking at the graph? Well, if you connect one end to the other end and you just do like a line, let's do a little example here. Is the slope positive or negative? Positive, so therefore this is a positive degree polynomial. Okay, so this is positive. Why would I care if it's positive? Who cares if it's positive or negative? Well, it tells me whether or not I need to put a negative in front. And since I don't. Since it's not negative, I just leave it. So this is simply y equals that. How about that? That's all it is. See, I told you. Well, what you need to know for the quiz is the relationship between the equation and the x-intercepts and the bounces and hitches. So I could give you the graph, or I could give you the equation and you make the graph. But the point is that you understand, and I'll tell you because I've taught this many times, is the thing that trips people up is the reversal of the sign. So because the x-intercept is -1, this blue one here, right, it has +1, but this over here, the intercept was negative. Because it's the 0. It's what makes it 0, because then y equals 0, and y equals 0 is on the x-axis. So that's what trips people up, is flipping the sign, or they just don't think of it as being the 0. You need to think of the binomial as being the 0. Sorry, the x being the 0 of the binomial. All right, ready for the next one? Ooh, yum. Let's see. Oh, yes. Which one do you want, B or C? Yep. Yeah, no? Okay, fine. I'll do B. I just did the whole thing again, didn't I? It's okay. It'll allow us to move on. So this one here, do you know what it is? Excellent. And anything else? What's negative? Okay, so where do I put the negative? Very good. And anything else? Yep. Yep. They both have a bounce, so they're both squared. So that means it's y equals this stuff. And that's good. We did it. That is our answer. Can you do the last one? Pause the video now and make your attempt, and then watch the explanation. And we're back. So this one here, yeah, go ahead, tell me. Tell me what it is. Did you notice that there's 3 parentheses? Yes, very good. Okay, so if 0 is one of them, so let me point that out right here. Here's this blue dot, right? So that means it's x minus 0. But do we need to write x minus 0? Not like that. I mean, you have to put something, but not the minus 0 part. So instead of writing minus 0, we just write it as x. And I can't move it. Well, anything else with the x? Well, let's just see. Let's just finish the other ones. What about the other intercepts? What do I put in the other parentheses? X plus 1. Okay, so this green dot here is going to give me x plus 1. And thank you, unnamed student. That is x. You can only be named if you're an adult. You are? Well done, Kayla. Somehow I doubt that. Are we done? Is this it?
Wait. No. You have to do x plus 1 to the cube.
No, you think it's a hitch? You think that negative 1 is a hitch? Where's the bounce? Where's the bounce? At 0. You don't have to put the minus 0, okay? Just leave it as x squared. So there you have it. Wow, that's it. Well, my friends, I hope you enjoyed that. I hope that was helpful to you. We all learned a little something about graphing these polynomials. Welcome back, and like, share, and subscribe, and buy my merch. Thank you very much, everyone. Have a good day.